Good morning. We will start session 3 on chapter sound. So in our previous session, we understood that sound requires a material medium for propagation. That is, sound can travel in air, sound can travel in solids, that is solids, liquids and gases. So we also understood that with the bell jar experiment, right? And the second thing we understood, how do we hear? That is, we can hear through our ears. What are the functions of the human ear, or how human ear functions, right? We understood about the sound. In today's class, we will understand what is frequency, time period, amplitude of the sound. Related to amplitude of the sound, what is loudness and pitch. First, let us understand what is frequency. But before that, let us first understand how do we define, or how do we understand that, or how do we draw a wave of a sound, right? Anything which causes disturbance in a medium, that creates a sound, right? So whenever there is a vibration, that means there is a disturbance set up in a medium which creates a sound. In your higher classes, you will be again studying in detail about the types of sound waves, that is longitudinal waves and transverse waves. Now here, we'll only understand about a sound wave. Let that be longitudinal or transverse, we'll only understand what is a sound wave. So whenever we talk about the sound wave, we draw it in this manner. So I can tell from this point to this point, this is one complete sound wave, right? From here to here, there is a disturbance created in a medium which is called a sound wave with respect to the time axis, right? Now, if I talk about the oscillatory motion, what is oscillatory motion? The to and fro motion of an object, pendulum or swing, that is an example for a oscillatory motion, right? So the to and fro motion of an object is related to a oscillatory motion. With that respect, we define frequency. The number of oscillations of an object, the number of oscillations an object takes per second is called as frequency. The number of oscillations an object takes per second. Now when I talk about an oscillation, now this is one oscillation. So this is second oscillation, right? So these are number of oscillations an object takes per second, that we called as frequency. So suppose if I am playing a music, it depends upon for how long I am playing a music, how loud I am playing a music. It's all about frequency. We'll understand much detail about that as we proceed further. SI unit of frequency is measured in terms of hertz. So 1 hertz is equal to 1 oscillation per second. Time period. The time taken to complete one oscillation is called as a time period. How much time do I take to complete one oscillation? That is called as a time period of the particular oscillation. The time taken for one complete oscillation of a sound wave is called a time period of a sound wave. Amplitude. The amplitude of the sound wave can be defined as the maximum displacement of the particles from their mean position. Now this is the mean position of an object, right? The maximum displacement. So this is the maximum displacement what a sound has taken. Now if I draw another wave here, so if I draw it like this, what do you feel? So which has the maximum amplitude? The first wave or the second wave? Of course, the second wave has the maximum displacement, that is, the second wave has a higher amplitude. Now simple, if I have to tell you, I am playing a music, then I just increase the volume. That means initially I was listening music in this amplitude, then when I increase the volume, I was listening to the music with this amplitude. So this was my first one, and this was after increasing the volume. So what did you notice here? As I increase the volume, what has increased? The loudness of the sound has increased. True? So my first time when I was playing the music, this was the amplitude of the sound. Second time when I increased the volume, this was was the amplitude. That means as the amplitude increases, loudness of the sound also increases. So what is the relation between amplitude and loudness of a sound? Let's understand that. So now let's understand what is loudness of a sound. Loudness of a sound depends upon the amplitude that we understood here. That is, in the second case, when I increase the volume of the sound, the amplitude increases. That is the highest displacement of the particle from the mean position, right? So it increases. So loudness depends upon the amplitude. That means higher the amplitude, higher is the displacement. Of course, yes. So loudness is directly proportional to the square of the amplitude. Now that means, let us just imagine the loudness of the sound is, loudness is measured in, first we'll understand, SI unit for measuring loudness of the sound is decibels. In yesterday's class we understood that 85 decibels, it can damage our ears, right? So assume that I will play a music with 10 decibels. Okay. So if I am playing the music with 10 decibels, then it is equally that amplitude also is 10 decibels. No, it's actually not that. What actually happens here is loudness is proportional to square, directly proportional to square of the amplitude. That means with whatever amplitude I am playing, if loudness is double to it, with whatever loudness I am playing, amplitude is double to it. That means if I am playing with 10 decibels, loudness, the amplitude is double to it, that is 20. Yes, it is not equally, it is twice the. Now here, when you understand that loudness is directly proportional to the amplitude, if I double the loudness, what will happen to the amplitude? Amplitude will be 4 times the loudness. Yes. So this is very important thing what you have to know. Since loudness of a sound depends upon the amplitude, loudness is directly proportional to square of the amplitude. A condition given, if I double the loudness, then amplitude will be 4 times because square of it. Okay. So the next part here, I said 20 times, it is not 20 times, it is square of it means 10 square of it, not 10 into 2. Okay, so usually they will not give you any numericals based on this, just you should know this here. You do not have any numericals based on any chapters. Hardly in some chapter we might have 1 or 2 basic sums. But here this is a simple thing what you should know here. Loudness is directly proportional to the square of amplitude. The relation between loudness and amplitude. The next part. We know that SI unit is in decibels. Pitch of a sound. Now what is pitch of a sound? How loudness is depending upon the pitch of a sound. Right? We all get to hear the word pitch, but actually what is a pitch? Let's understand here. The pitch of a sound depends upon the frequency of a sound. Higher the pitch, frequency of the sound is higher. Now that means if I just draw here, do you think the frequency is more? Of course yes. So higher the frequency, pitch is higher. Okay, I will give you another example here. What do you think in this? What do you think about this sound wave what I have drawn? What about the frequency? Frequency is less. Frequency is less. So what will happen to the pitch? Pitch also will be less. Right? But notice one thing. What about the amplitude? Amplitude is maximum when compared to this. Right? If amplitude is maximum or amplitude is high, what will happen to loudness? Loudness also is high. Keep it aside. Come back to this. Frequency is more. Pitch is more. What has happened to amplitude? Amplitude is less. Right? Based on that, I have given some examples. We'll try to understand much better. Drum. Sound produced by the drum has a low pitch. That means sound produced by the drum has low pitch, means it has low frequency, it has high amplitude. See, lower the frequencies, what will happen? Amplitude will increase. Now for example, now you have to run for a certain distance, but what you do, you don't run this way, you start running this way. But this is considered, not this is considered, right? So here what happens here, as the frequency decreases, the amplitude increases, right? So what is happening here? Sound produced by the drum, the pitch is low. Since the pitch is low, frequency is less. Since the frequency is less, amplitude is high. Simple things if you have to know, the sound of a drum can be heard very loudly. True? Yes. Now I have just left out blank so that you can analyze and you can fill that, and we will do that together here. Now sound produced by the bird has a high pitch. That is why, keep this figure in your mind. Sound produced by the bird has high pitch, means high frequency. That means what has happened to the amplitude? Amplitude is low. If there is a competition between beating the drum, and if I ask a bird that you have to produce sound sitting at your place and at a particular distance where the bird is producing singing, or the bird is singing as well as we are beating the drum, which sound will you hear sitting at your place? You can hear the drum sound rather the birds, right? A small example. Next, roaring of a lion has a low pitch. That means low pitch, less frequency. What about amplitude? Amplitude is high. Sound of a man has a low pitch. If he has a low pitch, lesser frequency, amplitude is high. Sound of a woman has a high pitch. If she has a high pitch, that means frequency is high. That means if frequency is high, what about the amplitude? Amplitude is low. Amplitude is nothing but we are talking about the loudness. Now last. Now you have to answer this. Sound of a baby has a high pitch. Of course, yes. High or low pitch? High pitch, because if it has high pitch, then what about the amplitude? Higher the pitch, more the frequency, amplitude is less. Lower the amplitude. Questions can be asked on 1 mark. Why woman has a high pitch and a man has a low pitch? Then about the sound, loudness of the sound. Anything question can be asked on that. Or why women have a low sound than the men, since they have a high sound. You have to explain here about the pitch. So in this concept, what you understand here is, if the pitch is low, that means the loudness of the sound is high. You have to only understand by these two figures, simple figures, and if you write this, you will be able to answer anything. If you know what is the pitch of the given sound, then you can tell that whether it has a high amplitude or high loudness is high or it is less, right? So this is about the pitch of the sound. Now the last part of this today's concept is, let's understand the difference between pitch and loudness of a sound. So let's just understand about the difference between pitch and loudness. So pitch depends upon the frequency of the sound. We already understood in the previous part, where loudness depends upon the amplitude of the sound. Pitch, here in pitch part, ear reacts to the frequency of the sound. That means how we are able to hear it. Wherein loudness depends upon the energy of the sound. How much energy is required to produce that sound. In pitch, the sound is either shriller or flatter. Now what do you mean by a shrill sound and a flat sound? Though it depends upon the pitch, that means higher in both the cases I have given higher pitch only. But here if you can see, the voice is crisp or the voice is very sharp enough to hear. Wherein here the voice, it has a higher pitch but a very flat pitch, what we can say, right? When we talk about loudness, it is about the amplitude, which is the maximum displacement, louder the sound. But in that loudness, we understand whether the sound is loud or the sound is feeble. So here I have written about the amplitude only, but the amplitude is differing here, louder or the feeble amplitude, right? So these are the basic difference between pitch and loudness. The most important thing here, you have to understand the concept of pitch and loudness. So if the pitch is high, frequency is high, amplitude is low. That concept, if you understand, you are very clear on pitch and sound part. So in today's class, we understood the concept of the sound, that is how a disturbance is created and a sound is produced. Through that, how we what are frequency, oscillation and time period, amplitude, how amplitude is related with loudness and pitch. So any doubt in today's class about pitch, loudness, frequency, amplitude, what we have studied, you can call on the same day of the video set. Thank you.